Alright friends, so let's continue with the third session of motion in a straight line. So far we have learned the concept of uh, displacement, we have learned concept of speed and velocity, we have seen the xt curves and how do you interpret them, then the concept of acceleration and vt curves and how to interpret these. So this is what we have already covered in session 1 and 2. Small videos of I have prepared for discussing this, right? So in short, whenever we are moving from one point to another point, say one city to another city, we are in motion. Suppose this is the object is my car, suppose, right? So this object is in motion with respect to other object, and that's why when we start this car, so initially the velocity, the distance is, you can say the start time is, I can consider time to be 0, I can say this distance to be 0, and initial velocity is also 0. Then what do? We accelerate, we increase the speed, right? So speed increases, and that's why we have alpha that is greater than 0. So we travel, right? Then we move at, once we accelerate and reach a certain safe limit, we run at constant speed, generally on a highway. So at that time, alpha is going to be 0, and at last we brake, because we want to stop at a particular point. So at that time, what do? Velocity we reduce, acceleration is also reducing or negative, and ultimately we stop, right? So this is a common motion we are coming across every day, rather very commonly, frequently, whenever we move from one place to another place. So we have motion, we have different categories: velocity increasing, velocity decreasing, acceleration positive, acceleration negative, and in some region or most of the region where we would like to run at a steady speed with zero acceleration, right? So this is how the motion in straight line is studied. This is motion in straight line, so motion in one dimension. So this is, suppose, my positive direction, then this is going to be the negative direction, right? So whatever velocity and acceleration in this direction will be considered positive, and the opposite direction will be negative, right? So direction is something which we assume before we study the topic, and accordingly our directions are nominated, right? Uh, Later stage we'll also discuss about the motion in up and down directions because of the gravity and all. So at that time the motion will be in straight line but in vertical up and down direction, right? So with this background, let's continue with the today's topic. Today would like to discuss the kinematic equations, right? So kinematic equations of uniform accelerated motion. Right? So uniform accelerated motion. That means the velocity versus time curve is a straight line with a positive slope, right? So let's see the situation over here. This is my y-axis, and here I have time. So I assume that initial velocity is this, and then it is moving with this slope. So this is initial velocity v0. This is velocity versus time curve. And after t time, say this is time t, the velocity has reached the level, say v, final velocity. So v0 is initial velocity, of course in meter per second. V is final velocity in meter per second after time t seconds, right? Let A be the acceleration in meter per second square. So this acceleration is now given by v minus v0 divided by t minus 0. Or can I not say that v minus v0 is equal to at? Or I can say that final velocity v is equal to v0 plus at. So this is the equation number 1 which we are going to use for motion. You can say equation number 1. So when you know v0, when v0, acceleration and time are known, we can calculate it using this equation, right? Very obvious. So this is equation 1 which is involving 4 variables, right? v0, v, a and t, after which any 3 will be known and the other will be unknown. So while solving the example, we'll see how to develop the habit of looking at the equation, right? So in equation generally, if one unknown is there, one equation is sufficient. So if you know what is to be calculated and if you know the equation, right equation if you can select, very easily you can solve any example, right? So this is the first you can say part of the kinematic equation. Now let's go to the second part. So second part deals with the distance. Suppose I want to find out how much distance is covered. So let's x be the distance covered in time t, of course with uniform acceleration, right? Situation is same. I have a uniform accelerated motion. This is t, this much width, this is 0, this is v0 and this is v. So this distance is v minus v0 and this much length is v. So now you can see that the distance is nothing but the area under the curve, right? So x is equal to area under b versus t curve. Very easily we can prove that if, see, the distance x, velocity is nothing but distance divided by time, therefore x is equal to v into t. So when we find area of a rectangle, we multiply two sides. One side is v, the other side is t. So in short, when you find area indirectly, you calculate x. So whatever is the v versus t curve, if you find area, ultimately you are calculating the x, right? So distance calculated, distance covered in this time can be calculated. Now if this area of this is to be covered, so I have to label so that I can very easily find out. Let me say this is A, B, this point is say C, D and E. So this area is nothing but area of can say rectangle BDEA plus area of triangle, the triangle which is in the upper side, that is B, C and D, right? So what is this? This area of this triangle is nothing but its one side is V0, the other side is T, and the area of triangle is 1/2 into the height of triangle is V minus V0 and the base is T, right? So this is the expression where you can find out x. Now we already know that A is nothing but V minus V0 divided by T, right? So V minus V0 is equal to AT. So if I substitute over here, I get V0T plus 1/2 A into T into T, or let me say it is V0T plus 1/2 AT square. So distance x can be calculated using this formula, very commonly, very popularly used formula. We'll see how to solve examples using. So this is equation number 2, where distance x is V0T plus 1/2 AT square. Where distance x is in meters, V0 is initial velocity, it is in meter per second, time t, it is in seconds, and acceleration alpha or a, is in meter per second square, right? So if you have initial velocity, if you have acceleration, if you know time, you can calculate the distance traveled in that particular time interval t, right? So that is the second equation. Let's go to the third equation. So this is the equation which we are going to use for deriving the third or alternate equation. So what is the area equation? X is equal to V0T plus 1/2 into V minus V0 into T. Now suppose if I simplify this, if I take T common, this is nothing but V0 plus V minus V0 divided by 2. So if I further simplify it, it is 2V0 plus V minus V0 divided by 2. So this 2V0 minus V0 is going to be V0. So it is T into V plus V0 divided by 2. Right? Now we already know that A is V minus V0 divided by T. Or can I not say that T is nothing but V minus V0 divided by A? Yeah, so I'll substitute over here. So it is V minus V0 divided by A is T, and the second part is V plus V0 divided by 2. So in short, it is going to be V square minus V0 square divided by 2A. And what is this? X. Or in other words, can I not say 2AX is V square minus V0 square. So this is the equation number 3. Now what is the beauty of this equation? That it is not involving time. So if you know acceleration, if you know initial and final velocity, you can calculate distance. So out of all these variables, if any of one is unknown and the other things are known, you can calculate it, right? So these are the three equations which we are going to use. What are these three equations for uniform accelerated motion? First, V is equal to V0 plus AT. Second, X, displacement distance traveled, X is V0T plus 1/2 AT square. And third, 2AX is equal to V square minus V0 square. Right? So equation 1, equation 2 and equation 3. So most of the examples which we are going to solve are using these three equations, which are known as kinetic equations of uniform accelerated motion. What do you mean by uniform accelerated motion? When the motion is having uniform acceleration, that is, velocity versus time curve is a straight line with positive slope, right? In addition, this formula is always true. That is v minus v0 divided by time acceleration. Basic formula is there, and velocity is displacement divided by time. So all these basic formulas are already known, and I hope you already know these formulas, right? So with these formulas, we are going to discuss the uniform accelerated motion related numericals, right? In addition to that, we had not discussed the concept of instantaneous acceleration. So instantaneous acceleration. So suppose for a particular time duration, I know what is velocity v1 at time t1 and velocity v2 at time t2. So I know that average acceleration is nothing but v2 minus v1 divided by t2 minus t1. But within this duration t1, t2, at a particular instant, suppose I want to find out acceleration. So that is called A. So how can you find out that? For that, I have to uh, uh, limit this time duration delta t. What is delta t over here? Which is t2 minus t1. This should be very, very small. So should I say it is delta t tends to 0. So at that time, the difference of voltage is called, you can say delta V, and this is delta T. What is delta V? It is the change in velocity. Delta T already written, change in time or time interval, right? So this is the instantaneous acceleration, and this is mathematically given as dv by dt. So if you differentiate the velocity, you can say velocity, if you have a mathematical expression of velocity with respect to time, by differentiating v, you can get instantaneous acceleration A, right? So this is something which is application of mathematics to find out instantaneous value. Also, if you have a VT curve, something like this, right? Then instantaneous acceleration is nothing but a tangent to the point. Suppose this is the point at which you want to calculate the instantaneous acceleration. So just find out the tangent at this point, and slope of this line is going to give you the instantaneous acceleration. Right? So this is how, and this is the tangent. This is the concept of instantaneous acceleration. Graphically, this is how you can find out. Mathematically also you can find out, but provided you should have the mathematical expression of velocity in as a function of time, right? So this is the application of mathematics in physics. So with this I'll stop over here. This was the session in which we had derived the kinematic equations, and in now next session onwards I will solve different category of problems based on the motion of straight line, right? So thank you.